Okay, students, you should have section 6.3 notes out on the isosceles triangle theorems. The objective, students will use isosceles triangle theorems to determine unknown lengths and unknown angles of triangles. I'm going to go through a few of these theorems to help you understand each one. We're going to draw a picture as we talk about them. So the first one says the isosceles triangle base theorem. This says that the altitude to the base of an isosceles triangle bisects the base. Now the key word here is altitude. Anytime we draw an altitude, it's straight up and down. So it's going to make a 90-degree angle with the base. So we can get our straight edge out. And we're going to try to make this as best we can for the sake of time to look like it's 90 degrees here. Okay. And what it says here is that the altitude bisects the base. So that means this length and this length are going to be the same. Now notice, if we did an altitude, then this should be 90 degrees. Okay, the next theorem is the isosceles triangle vertex theorem. Vertex refers to this top angle right here. The bottom two angles are our base angles that are congruent. So this is the angle that's different. The altitude to the base of an isosceles triangle bisects the vertex angle. So this word bisects here means that it cuts it in half. So here's my vertex angle, and if I draw the altitude to the base, so it's the same line I drew here, if I draw it to the base, it also cuts this angle in half. So we're going to draw that same line. Because of the angle of my camera, it doesn't look like it's as straight up and down as it is, but we'll try it again. So if we draw the same line, the altitude again, here, it cuts this angle in half. So we can draw that like this to show that those two angles are congruent. Okay, now if we pay attention, then it's still that same, since it's the same line, would have cut the base also in half. The third theorem here says the isosceles triangle perpendicular bisector theorem. That's saying if we draw the altitude from the vertex here of an isosceles triangle to the perpendicular, or to, let me say that again. The altitude from the vertex angle of an isosceles triangle is the perpendicular bisector of the base. So all of those words are really just saying that this is the same line that we drew here and here. We drew the perpendicular bisector. So if we draw this perpendicular line right here, it's actually called the perpendicular bisector. So if we put all those together, cuts those two lines in half, cuts the angle in half. Now remember, this is an isosceles triangle, so these two sides are also equal. We should probably go back up here and make that note on the rest of our notes. So all three of those pretty much go the same. They talk about the same thing. I'm going to circle those all in blue. They're all the same line. And then we're going to talk about two that involve the base angles here. So this other one, we'll do it in red. Circle these two. It's the isosceles triangle altitude to congruent sides theorem. This says, in an isosceles triangle, the altitudes to the congruent sides are congruent. So that means if I take my base angle here, and I draw an altitude to the other side, now it's going to be kind of hard to see. We've got to draw a line that's perpendicular to the other side. It's going to kind of go something like this on this triangle. And we do the same thing with this side. So we're just drawing a line perpendicular to the other side. Okay? So these two lines are actually congruent here. Okay, let's look at the next one. An isosceles triangle angle bisector to congruent side theorem. So remember what bisector means, and it's an angle bisector. So we're going to take our base angles here and we're going to cut them in half. So if I cut this angle in half and draw a line to the other side, like this, I'm going to do the same on this side. Those two lengths are also congruent. So we can denote that here, all the way across. So from here to here is congruent, and from here to here is congruent. They're the same size. So let's put some of these into action and see what it looks like. On example 1, it says determine the value of x in each isosceles triangle. So the very first step is to identify that it is in fact an isosceles triangle. We can see that by showing right here that these two sides are both 8 inches. That is enough to tell me that that is an isosceles triangle. And this line here looks an awfully lot like these ones up here. It's the perpendicular bisector, which does 3 things. It cuts this angle in half, it cuts those lengths in half, and it's the perpendicular line to the base. So this problem is a lot easier than it looks at first. If this side is 32, this side must also be 32. So x equals 32. On number 2, the first step is to identify that it is in fact an isosceles triangle. We can do that by showing right here this length is 20 and this length is 20. So these two angles must be the same, and they're my base angles. So this line right here is our perpendicular bisector, which means it cuts those two angles in half and the bottom two sides. So if the whole thing is 26, half of it from here to here would be 13. Okay, turn the page. Let's see, move it down just a little bit more. Okay, determine the value of x in each isosceles triangle. So if we look here at this diagram, let's first find out where x is. Okay, it's right here. It's asking me the distance all the way from here to here. Now I know this is an isosceles triangle because it tells me that side's 25 and that side's 25. So these two angles must be my base angles. And when I draw an altitude to the other side, right here, and I can tell it is an altitude because of that right angle, then this length is equal to that length. So if this length is 24, then this length must also be 24. So x equals 24. Okay, number 4. This one uses a little bit more of our triangle sum theorem as well, the angle theorem. If we look here, we've got an isosceles triangle. It's noted here with the lines. And this base angle is defined as 4x plus 1. So this base angle must also be the same, 4x plus 1. Now I know that all the angles in a triangle must add up to 180 degrees. This is 1/2 of that top angle. So I'm going to have to multiply it by 2 here to find out what this angle is. So I can say, if I put this all together, 2 times 2x minus 7, and then I need to add 4x plus 1, and then plus 4x plus 1. That means this plus this is going to give me 1, so equals 180. So the first thing I need to do is distribute my 2. So 2 times 2x is 4x. 2 times negative 7 is negative 14. And then I have plus 4x plus 1 plus 4x plus 1 equals 180. So you need to combine everything that's on the same side first. So I have 4x here, another 4x here, and another 4x here. So that makes 12x. Okay, and sometimes I like to cross them off to know I've used them. Then I have negative 14 plus 1 is negative 12 equals 180. Now I'm still trying to get x by itself, so I'm going to add 12 to both sides. And I get 12x equals 192. Divide both sides by 12. X equals 16. Wait for that to come back on. X equals 16. Okay, now don't just take my word for it. Let's check this. Let's put this in and make sure that all these angles add up to 180, because if we made a mistake in our arithmetic somewhere, we'll find it this way. So I'm going to put 16 and I'm going to plug it in for 4x plus 1 here. So I'm going to go 4 times 16 plus 1, and I get 65. That means this angle is 65 and this angle is 65. Okay, now let's check our top one. It says 2x minus 7. So I need to go 2 times 16 minus 7, and I get 25. So this whole thing would have to be double that, which would be 50. Now let's add all three of those numbers together and make sure we get 180. So we have 50 plus 65 plus 65, and we get 180. That way we know we did it correctly. Okay, number 5. The front of an A-framed house is in the shape of an isosceles triangle, as shown in the diagram. In the diagram, HK is perpendicular to GJ. So let's draw that line. HK is perpendicular to GJ. Then GH is congruent to JH. So that is this line, GH, right here, is congruent to JH. And the measure of HGJ, so we start at H, we go to G and to J, so that's this angle, is 68.5 degrees. So we don't have a lot of room there, so let's draw a little arrow and write 68.5. Use this information to determine the measure of GHJ. So that's this angle right here that we're looking for, that whole angle, not just half of it, but the whole thing. So we can figure this out first by realizing that this is an isosceles triangle. So this angle, HJG, is congruent, and it is also 68.5. Now I know that this angle plus this angle plus this angle needs to equal 180 degrees. So I can set that up. Let's add those two together and see what it equals. 68.5 plus 68.5 gives us 137. Okay? So this angle up here needs to be the difference of that. So if I take 180 and I subtract 137, I get 43. So we can say that the measure of angle GHJ equals 43 degrees. Okay, let's look at the next one. When building a house, rafters are used to support the roof. The rafter in the diagram has the shape of an isosceles triangle. In the diagram, NP is congruent to RQ. So here's NP. Sorry, it says perpendicular to RQ. NR, this line, is congruent to NQ. So I have an isosceles triangle. NP is 12 feet. Let's put 12 right there. And RP is 16 feet. Use this information to determine the length of NQ. So since I don't know what NQ is, I'm going to label it as X, because that's what we like to do in math. Now notice we got to use some of our theorems. So what is this line right here? It tells me it's the perpendicular bisector, which means that this length right here has to be the same as this length. So I can say that this is 16 as well. And now I have this right triangle right here on this side. If we look at this half. And I'm missing my hypotenuse, but I know two sides. So we like to use the Pythagorean theorem to solve that. So we have 12 squared plus 16 squared equals x squared. 12 squared plus 16 squared equals x squared. Notice and remember that order in math has to go the two legs squared equals the hypotenuse squared. Okay, 12 squared plus 16 squared is going to give me 400. You can do that on your calculator and see that that's true. And then when I have x squared, I got to figure out what x is, not x squared. So I'm going to do the opposite, and I'm going to square root both sides. And the square root of 400 is 20. So this side right here is 20. Okay, this last one, the hinge theorem, states that if two sides, now this is kind of hard to understand, so we're going to go slow. If two sides of one triangle are congruent to two sides of another triangle, as we can see actually down here, it says this side is congruent to this side, and this side is congruent to this side right here. Okay, so they don't have to be exactly the same, but they both share two sides. They're congruent. And the included angle, so that's the angle in the middle of the two, of the first pair is longer than the included angle of the second pair. So notice we have that. And that should actually say larger, not longer. So let's change that to say larger. So this angle is larger than that angle. Then the third side of the first triangle is longer than the third side of the second triangle. That's a really complicated way to say that, but of course that makes sense to us because we know that the side opposite of those two angles, if this one's bigger, then that side's going to be bigger. So we need to draw this. We're trying to decide, we're going to replace the question mark with a greater than or less than to make a true inequality. So we need to decide, is SP bigger or GQ bigger? But we have this theorem that says if this angle is bigger than that one, the included angle, then this side is bigger. So we're going to replace the question mark with a greater than sign. Okay. Last one. This one gives us the sides, and we need to decide which angle is bigger, angle E or angle T. Okay, so we have, it's the hinge theorem because we have this side is congruent to this side, and this side is congruent to this side. But the third side is different. And since the third side on this one is bigger than the third side on that one, that means the angle opposite is bigger than that angle. So angle E is bigger. So angle T is less than angle E on this one. Okay, your assignment to go along with this, since it comes back in focus, is assignment pages 38 through 40 in your yellow book. That will be due next time you come to class.